evening I would like to introduce you to the new European Passive House standard. There are about 10,000 houses being built in Europe, and it's a pretty amazing standard in leapfrogging of the standards what is being used up to this point. I'd like to go through a quick definition of a passive building. Passive building.
I can't hear you.
A passive building uses the natural energy flows around the building, like solar, and wind. And with the passive European passive houses, they have developed the concept of passive houses further, and they now integrate efficient active components, such as a heat recovery ventilator, and all those devices which are used in those systems. They save much more energy than they use or control. In Europe, it's a big movement. There are, since 1998, more than 10,000 houses have been built. The huge conferences with 1,000 people once a year in different European cities. And there's a huge support from building scientists, universities, architects, manufacturers, and by now politicians are very much behind this idea of building new houses. And just on the last conference in April, we heard that the European Parliament, what is responsible for 350 million people, is considering to adopt the passive house standard from 2011 onwards. We think that will have tremendous effects on how we build also here in the United States, because huge amount of monies are being spent to develop those technologies. And this passive house just was a winner at the Solar Decathlon in Washington, D.C. Last year. Very sophisticated house with 20 universities from the States and other countries. And now the first passive houses have been built in the US. There is a first house in Urbana, Illinois, built by a German architect, and we just had last year was a second passive house conference also in Urbana. There are houses being built in Martha's Vineyard. There are probably about 10-15 houses have been built in the States. So to describe the passive house standard, there are 4 benchmarks what these houses have to meet. And the first is you want to have in a passive house what is very tight, a good air quality. So you need to have a 24-hour balanced ventilation system, which means you want to get in every room fresh air, so to remove pollutants and also remove a possibility of mold, so that humidity doesn't get stuck in any room. That is very, very important for a tight house. The second one is a comfort. Without a comfortable indoor temperature, you wouldn't probably want to live in a house, a passive house. So it's very important to keep a constant temperature in the house, what is at least 68 degrees. And because the houses have so much insulation, the lag time in the house is up to 200 hours, which means the temperature swings when it gets cold. It takes up to 200 hours before the house totally cools down. And also takes 200 hours to heat up the house. So you want to keep doing the winter months your heating system on all the time. You also want to have a reduced sound pollution through the big walls and triple glass windows. And you also have a reduced draft, because the window insulation keeps the surface of the inside of the window much warmer, so you don't get the natural draft what you have in every other house. That helps you tremendous with the comfort in the house. It helps you sitting in front of the window in the coldest day of the year. What makes it much more comfortable, and you also have more usable space in your building. Then those houses have a very, very high energy efficiency. They use super insulation. For this climate, probably use 6 inch to 18 inches in the wall, 50, 60 at least in the ceiling, probably 40 in the foundation. We use a highly efficient heat recovery ventilator with at least 75% efficiency. Triple glass windows, and then it's very important to have a thermal bridge-free construction. That means all the material, like wood, what reaches through the insulation should be eliminated as much as possible. Because in a standard house you might lose 5% of the energy, but in a passive house you might be about 50% of the energy loss. So that is very important to consider in the planning process. And then the houses have to be cost effective, because otherwise it would be a niche product. So a lot of effort was done to find the break points to make the houses cheaper. And the life cycle cost of those houses are normally much lower than a standard house. So it's really like, it becomes a no-brainer to build those kind of houses. It's cheaper, and you have a much better quality home with very low energy cost. So it could be your retirement system built into the house. You also have very reduced maintenance costs because you have a very simplified heating system. More or less you just have an ERV with a small backup heating system. And also the ventilation system can be very compact because we have triple glass windows with wood insulation, so we can supply the air from vents from inside the building. So we don't have to run the vents underneath the windows, create thermal bridges, and create like much higher draft in the building. And so here, like many types of buildings have been built, from single-family houses, townhouses, industrial buildings. Schools have been built. You really have a choice of materials. You can use, this is TGI walls with cellulose insulation. You can use ICF, you can use stone, you could use straw, you could really use anything if you meet the R value and also the air tightness and the protection against humidity transfers through the walls. So they also, you can really use any design, so an architect is relatively free to choose different forms. Europe is using very modern designs right now, but you can really use anything you like. And this is a school in Austria. I've been in this school. They remodeled this school, and they used before 180 kilowatts per square meter per year in energy. And afterwards they used only 11 kilowatts per square meter per year. So they had a reduction of 15 times the energy usage. And one of the features they use there, they have these massive earth tubes that run along underneath the whole building. And that saves huge amount of energy to preheat or cool the building. And so in order to establish the passive house, or this idea, you really need a standard, because without a standard you can't compare anything. And in Germany, or in Europe in general, it's much easier to compare energy because everything is rated in kilowatt. Here